in Government College of Engineering, Salem, and he completed his ME in Power Electronics and Drives in College of Engineering, Guindy, Anna University, and he completed his PhD in Anna University, and he is having totally 18 years of teaching experience, and he has published around 50 journals in national and international, and he has presented around 25 papers in the conferences in national level and international level. And he is a research supervisor of Anna University, and he is active researcher. Uh, and he has organized many programs, state level programs and national level programs. So it is fortunate to have such an eminent personality with us today. So on behalf of you and my own behalf, I welcome Dr.C. Govindaraju for today's session. So I hand over the session to Dr.C. Govindaraju. Sir, please.
Thank you, sir.
Yes, sir. Go ahead, sir.
Fine, sir. I share my screen. Please confirm then.
Yes, sir. Yes, sir. Visible, sir. Your screen is visible.
Very good evening to all of you. I'm very happy to be a part of the Atal FDP organized by Vivekananda College of Engineering for Women. At today's session, just I want to share a few points with respect to the fuel cell electric vehicle, which is upcoming technology in that electric vehicle scenario. Sir, am I audible, sir? Shall I continue?
Yes, sir. Clear, sir. Your voice is clear. Everything is okay. Will you please proceed, sir?
Fine. In this today's session, just I want to introduce the basic concept about the fuel cell and how fuel cell supports for electric vehicle, application domains of the fuel cell electric vehicles, and what are the research issues which are currently present in that fuel cell electric vehicle, which may be useful for the research scholars who are doing that research in this electric vehicle domain. Finally, we will conclude with some valid points. Uh, Everyone feels that we need a transportation. In present scenario, we are using vehicles with the conventional fuels, diesel and petrol. And uh, as we know the problems of using fossil fuels, so day by day the availability of fossil fuels getting reduced, and another problem is the energy efficiency stress during the conversion, and it produces the harmful hazards which will have a global warming issues. So we think about the alternate energy resources which is which can be used for transportation, that we can claim as a green transportation. It means that the vehicle which will not produce a harmful gases to the environment. So that kind of transportation we are terming as green transportation. Electric vehicle is one kind of green transportation. Electric vehicle, it uses one or more electric motor as a traction motors instead of IC engines for the conventional vehicles for propulsions. This is about the basic structure of the electric vehicle. Instead of IC engine, where we are using electric motor, which converts the electrical energy into mechanical energy. That mechanical energy helps for vehicle propulsion, and we need a electrical energy for the electric motor operation. So that we are getting from the battery. Battery is energy storage systems here, and that if you we can easily charge the battery from the available electricity, and with the help of which we can operate the electric vehicle so that it will not produce any harmful gases. It's supposed for the green transportation. We can classify the electric vehicle as a pure electric vehicle, hybrid electric vehicle, fuel cell electric vehicle as kind of hybrid electric vehicle. Then third category will be a plug-in hybrid electric vehicle. This is about the broad classification of electric vehicles. When you take about that the pure electric vehicle, uh, which depends upon the operation of electric motor alone for propulsion. Hybrid electric vehicle where we are using two or more energy resources or power sources for operating that vehicle. For example, IC engine plus the battery operated vehicle is an example of hybrid electric vehicle, or fuel cell plus battery, that is another example of hybrid electric vehicle. So in this session, we are focusing on the fuel cell electric vehicle. Again, it comes under the hybrid electric vehicle. The third category will be a plug-in hybrid electric vehicle. Uh, it is a hybrid electric vehicle with its own onboard electrical charger. It means that we can charge the vehicle quickly, and we can operate that vehicle as an electric vehicle in parallel to the vehicle operates with IC engine. This is kind of electrifications needed where you look into that. This is about the conventional vehicle where we are using a IC engine. IC engine operates with the diesel or petrol, so which will produce the mechanical energy which helps for the transmission of the vehicle or vehicle propulsion. In that a pure electric vehicle where we are using electrical machine for producing the mechanical energy, the same machine can operate as a generator. While applying a brake, it acts as a generator so that the energy during the braking it will be converted back and stored in the battery, so that we are saying as a motor per generator. It is not a separate device. It's a single system that accesses the motor as well as the generator. Actually, it is called electrical machine. This is about the pure electrical vehicle. Whereas in the hybrid electric vehicle, we have two options for producing that mechanical. One thing will be a conventional engine that is operated with the conventional fuel. In addition to that, in parallel to that, the electric vehicle. So again, these two are independently operate and provides the mechanical power for the propulsion. This is about the basic structure of hybrid electric vehicle, which combines two power sources or energy sources for electric propulsion. The basically we have a combination with the diesel engine with electric motor. That is one combination. Another combination will be a fuel cell and battery. So we are replacing the diesel engine with the fuel cell for main source, and the battery is for secondary energy source for the electric vehicle. What is why we need a hybrid electric vehicle instead of pure electric vehicle? Or instead of the conventional engine means, first one will be it's capable of regenerative braking. In conventional vehicles where we are using a mechanical braking and the corresponding control needed, whereas in hybrid electric vehicle regenerative braking is possible, so it is energy efficient one as compared to the IC engines. So electric motors and it's supporting the power converter for controlling the electric motor has a less vehicle weight, so that it reduces the vehicle weight. Definitely the fuel efficiency is getting increased. Actually, how the fuel efficiency will be calculated in that conventional engine is very simple, because the fuel is a input, inlet to the IC engine, and some losses will be present. The remaining power is converted into the mechanical power. So that will be considered for finding the efficiency. Whereas in the hybrid electric vehicle, where we are calculating the fuel efficiency starting from uh, the fuels which will be needed for electricity production, and also the fuels which will be needed for our conventional fuels. All the things are to be considered, and all the stages are to be considered for finding the fuel efficiency as compared to the conventional vehicle. The electric vehicle and hybrid electric vehicle has a more efficiency and fuel efficiency. Emissions obviously is getting decreased, and so when you are using a hybrid electric vehicle, even it is combined with IC engine, the global warming pollutants is reduced by 1/3. Another thing will be we are more dependent on the fossil fuels. So when we are using that hybrid electric vehicles, we can reduce the dependency. And another thing will be IC engines, where the thermal efficiency will be low, whereas our electric motors, the efficiency will be higher. So when the overall efficiency for the energy conversion will be better compared with the conventional engines. So these are the some of the futures. So we are moving towards that hybrid electric vehicle. Um, Here we were looking that fuel cell car. Fuel cell is an energy source for this car, so that this car or vehicle is termed as a fuel cell electric vehicle. What is called a fuel cell means it is an electrochemical device which converts the chemical energy into electrical energy in a single stage. Fuel cell is very similar to the battery, but there is a big difference in between a fuel cell and battery. Whereas a fuel cell is an energy conversion device, which converts the fuel, normally hydrogen and oxygen, into the electrical energy, whereas the battery is the energy storage system. So just it stores the energy during the charging, and where it is when it is needed, it is get back that energy from the battery, that is in the discharging mode. Here, the fuel cell produce electricity which used for driving the motors, and also powering the remaining parts of the electrical vehicle systems or accessories present in the electric vehicle. So we can claim that the fuel cell electric vehicle as the hybrid electric vehicle. Again, it is the pure nature of electric vehicle. It won't produce any pollutions like a conventional hybrid electric vehicle, which will be operated with a combination of IC engine and battery. Okay, so what about the futures of that the fuel cell electric vehicle, especially for hydrogen fuel cell electric vehicle? It is economically feasible, and it's an interesting alternative to the battery operated electric vehicle, where we are more focused on that the longer range of longer ranges and shorter refueling time. Normally the main problems with battery operated electric vehicle is it is not suitable for the long distance travel, because we need a recharge at the intermediate point, and again it takes a time to recharge. Whereas in the hydrogen fuel cell electric vehicle, or simply fuel cell electric vehicle, here there is a no problem about the distance. You can drive your vehicle at any long you need, and because here the hydrogen is the fuel, so we can easily and quickly refill the fuel, just like our normal petrol or diesel car, where we can fill the fuel tank with petrol and diesel. The heart of that fuel cell electric vehicle is the fuel cell. Is normally the polymer electrode membrane hydrogen fuel cell is used. That is called a PEM fuel cell, which is more suitable for the electric vehicle applications, in which the chemical reaction takes place in between the hydrogen and the oxygen that produce the electric energy, which helps for the propulsion, which helps for operating the traction motor. Basically, it is electric motor which helps for the vehicle propulsion. Normally, in addition to that fuel cell, there is a small size battery is used as the secondary energy source, which will take care about the some kind of energy requirement during the acceleration. And as electric vehicle, it is operated with regenerative braking. So while applying a braking, so the same machine accesses the generator and it produces the electrical energy. That electrical energy is getting back and stored in that electrical energy getting back and stored during the braking. So for that we need a battery, but the size of the battery is not equivalent to the battery requirement for the pure electric vehicle. Another thing will be, as we know that the fuel cell is a modular nature, so we can increase the size of the fuel cell so that it is suitable for even very long distances. And also the vehicle can be designed for bigger in sizes, for example buses and truck vehicles and so on. Hydrogen fuel cell electric vehicle is clean in nature because it won't produce any harmful gases, and also it won't produce the noisy environment. It is the noise free operation, and it will not produce any pollutions, so that it is the environmental friendly. And also fuel cell electric vehicle is more efficient than the conventional IC engines. We can easily refill the fuel. Here hydrogen is the fuel, we can easily refill quickly, and it is suitable for the long distance travel. And another thing will be, we are claiming that the hydrogen vehicles or the fuel cell electric vehicles operated with the renewable energy sources, because normally we are producing the hydrogen and oxygen from the water, so the water is freely available, and so that we can claim that it is quite environmental friendly. Another thing will be, here we can increase the travel distance or the range by increasing the size of the fuel tank. So the hydrogen is a fuel, so we need a hydrogen fuel tank for the fuel cell electric vehicle, which the size can be increased so that it can be modified as for buses and the truck vehicles. And air quality while operating the fuel cell electric vehicle, the energy savings, because we are not dependent on the grid supply, because we are producing the electricity by our own with the help of the water which is freely available. And the greenhouse the emissions also will be negligibly small, so that the fuel cell electric vehicle will be a better choice as compared to the battery operated electric vehicle. Again, it needs the electricity which depends upon the grid supply. Again, the fuel cell electric vehicle, it's a good choice as compared to the IC engine based vehicles. A small comparison of how the hydrogen as a fuel will produce a more power than the battery operated vehicles. And another thing will be called conventional fuels. Even if you take about the lithium ion battery, uh, the energy density around 600 kilojoule per kilogram, whereas the hydrogen as a fuel energy density will be 120 megajoule per kilogram. Even we are assuming that the efficiency of the fuel cell around 30 percentage. It's just I'm assuming that the efficiency around 30 percentage. So 120 megajoule. So in which the 30 percentage will be around 40 megajoule per kilogram. 40 megajoule means it is equivalent to 40,000 kilojoule per kilogram, as compared to 40,000 is a bigger number as compared to 600. So, so the hydrogen fuel cell is a good choice, and it is uh, as compared to the battery operated vehicles. This is about a small introduction about the fuel cell electric vehicle. Now I want to start with the main modules which will be present in the fuel cell electric vehicle. The main module is the fuel cell. Just we want to look into that how fuel cell is working, what are the types of fuel cell, and what about the basic characteristics of fuel cell, and what kind of supportive systems needed when you are using a fuel cell for our electric vehicle. Basically, fuel cell is an electrochemical device which converts the chemical energy into electrical energy directly. It is a one-stage energy conversion device. So the energy conversion efficiency little higher as compared to that IC engines. Already mentioned that you have a big difference with the battery, but fuel cell is a similar nature with the battery, but the fuel cell is different, battery is different. Battery is energy storage device, fuel cell is energy conversion device. This is about the basic structure of a fuel cell. Uh, a, a fuel cell combines the fuel, here hydrogen is a fuel, with the accidents, the oxygen as accident, which uh, that combines the hydrogen and oxygen, and during the chemical reaction the electricity is produced. As a byproduct we will get the heat energy and water. Again we can split the water is actually H2O. We can split H2O into hydrogen and oxygen. That hydrogen and oxygen is again is input to the fuel cell. So where the water is available, we can easily generate we can generate, not easily generate hydrogen and oxygen. Hydrogen, that hydrogen is a fuel for the fuel cell that produce the electricity. Here during the chemical reaction, heat is produced. That heat can be used for cogeneration purpose. When you are looking to the basic structure of the fuel cell, it is a simplest structure. It consists of anode, cathode, and in between there is a membrane. And in order to speed up the chemical reaction, there is a catalyst which will be provided in the surface of the anode and cathode. First, the anode. Actually, the anode is the negative part of that fuel cell. Basically, in the battery, anode is positive terminal, whereas here there is a negative terminal. In the anode side, we are sending, or we are giving that hydrogen as the fuel, in which that hydrogen will be split into hydrogen ions and the electrons. The cathode is another side of the fuel cell, that is the positive plate of the fuel cell, in which we are sending the oxygen. There is a membrane which is called electrolyte in between the anode and cathode, that is called proton exchange membrane. The speciality with this membrane, so it will not allow the electrons, it allows only the ions, it blocks the electrons. And in the anode side and the cathode side, it is coated with catalyst that will speed up the chemical reaction, that will speed up the chemical reaction. So a lot of research is going on to invent the new low cost the catalyst uh, the earlier they used the platinum coated as a catalyst. So what about the operation is very simple. Uh, we are sending that the hydrogen the anode side. So normally the hydrogen will be sending with a particular pressure and temperature, so that the hydrogen molecules will be split into H plus ions and the electrons. Uh, this is about the anode part of the fuel cell. This is about the cathode part of the fuel cell. Uh, uh, in the anode side, we are sending the hydrogen with specified pressure and the temperature. And here the hydrogen will be split into H plus ions and the electrons. In between the anode and the cathode, there is a membrane. So the membrane allows only the H plus ions. It blocks the electrons. So by force, these electrons will be moving through the external circuit. In the cathode side, the again the oxygen, pure oxygens will be sending in the cathode side, and this oxygen will combine with H plus ions and the electrons through the external circuit that forms as a H2O. That is the water, and that is a byproduct. And during the chemical reaction, and the huge amount of temperature is produced, and so because of the electron flows through the external circuit, so we will get the DC output from the fuel cell. Normally, the single fuel cell is capable of producing the lower voltage and the lower current. For example, here the fuel cell voltage will be 1.23, which seems to be very less, and the current also will be very less. This is about some chemical formulas which supports for the fuel cell operation. Actually, the fuel cell converts the Gibbs free energy of the chemical reaction into electrical energy. Under the isothermal condition, it means that it operates with constant pressure and constant temperature. Uh, is Gibbs free energy is a thermodynamic the energy from the fuel which operates, that chemical reaction operates at the constant temperature and pressure, is given by this is the energy outlet from the fuel cell, that is equal to the change in the Gibbs free energy. It is a reversible process, so the sign becomes negative. That is equal to N into F into E. What about N? That is the number of electrons produced in the anode during the chemical reaction. F is a Faraday's constant, and E is the reversible potential produced by the fuels. And this is about the energy equation of the fuel cell. This amount of energy produced during the chemical reaction. When you consider that just 1 gram of hydrogen, which will combines that the half gram of oxygen, so at the atmospheric, 1 atmospheric pressure with the temperature of 25 degree, which will produce the energy of 118 megajoule per kilogram. Uh, when you consider that the number of the electrons during the process is 2, the maximum potential from the fuel cell at this condition is 1.23. This is about this. There is a this standard operating condition. Okay, so we want to find out the potential with actual operating condition, so that we can derive with the Nernst equation. E is equal to E naught plus R into D divided by N into F, logarithm of CH C naught power of CH2O. Whereas this is called the E naught, we can claim as a no-node potential or the reverse potential at the standard operating point, or specific gas constant T temperature, and N we know the number of electrons produced, a Faraday's constant, logarithm of this is about the concentration of hydrogen, oxygen, and the byproduct H2O, that is water. Basically, we have a different types of fuel cell. The fuel cell classification again based on the type of fuel input for the energy conversion and the type of material used for the anode, cathode, and membrane. There are different types of fuel cells available. The polymer electrode membrane fuel cell, direct methanol fuel cell, alkaline fuel cell, phosphoric acid fuel cells, molten carbonate fuel cell, solid oxide fuel cell, regenerative fuel cells. Among these fuel cell, PEM fuel cell and alkaline fuel cell is more suitable for the electric mobility applications. This is about the broad classification of the fuel cell, what type of electrode used, what about the operating temperature, what about the stack size and power producing capability, efficiency of energy conversion, application domains, and advantages and drawbacks. Actually, among these various the fuel cell, the PEM fuel cell is a preferable choice for the electric mobility applications where the operating temperature will be less. That is the one of the factors to be considered. Even though the power output will be around 100 kilowatt, okay, that is a stack power output. The operating temperature is less. So that is the primary requirement for our vehicle movement. Otherwise, we cannot operate the vehicle and we cannot, I mean, the vehicle, passengers inside the vehicle is not, they are not comfortable. The solid oxide fuel cell is more suitable for high power energy consumption for high power energy source, that is a standby energy source. That is more suitable for the grid integration and more suitable for residential and commercial buildings. Actually, the Bloom servers is comes under the solid oxide fuel cell, so they are more popular with the standby power supplies and like a DC genset. Uh, Actually, this how you choose that fuel cell for the vehicle applications. It is based on the size because we need a compact fuel cell and cost. So obviously, this is a major fact because why the fuel cell as the technologically it is a proven technology and but commercially still it is not in the we cannot say it is a success. So still there is a question mark about the commercial availability of that fuel cell because of the cost of the fuel cell. So other parts of the electric vehicle is no okay, but the cost of the fuel cell is higher. Again, we have to choose the fuel cell which have a low cost. And the fuel cell a little slow dynamic, so we that start of transient time also very important aspect because we want to quickly start the vehicle, we want to operate the vehicle immediately, we have to operate the vehicle. Another thing will be the complexity of control needed for the fuel cell electric vehicle, because the fuel cell itself is a complex in nature, and what kind of controller needed for the fuel cell operation. Based on this criteria, the proton exchange membrane is that is a PEM fuel cell is a good choice for the mobility applications. These are the attractive characteristics of the fuel cell so that you can easily compare with respect to the other groups of vehicle. One thing will be a higher energy conversion efficiency. Higher energy conversion efficiency means compared to IC engines, not compared with generators. And modular design. Actually, what we are looking is a single cell. The single cell is capable of producing only a minimum voltage for around 1 to 2 volt, and also the current also will less. So we want to add that fuel cells in series in order to increase the voltage rating, and we are increasing the fuel cells again in parallel, increase the current rating so that it becomes fuel cell stack. So the number of fuel cells in series and parallel is It's according to the power requirement from the fuel cell. So we can add any number of the fuel cell in series and parallel. So the creation of the fuel cell stack is a modular structure. So we can increase the size as you like. That is the greatest advantage with respect to the fuels. Fuels flexibility. We can use hydrogen or we can use the natural gas also. Low chemical pollution, it won't produce any harmful gases like your IC engines. Low acoustic pollution, it is a noise free operation. uh, it produces the temperature, it produces a heat. That heat can be used for cogeneration purpose or other purposes. um, it is a better response with respect to the quick load change. Because of these features, the fuel cell is a more attractive part for electric vehicle. As already mentioned, that the single cell is not suitable for the practical study. So normally the cells are connected in series and parallel like a battery array. Here it is termed as a fuel cell stack with a proper voltage and power. So in the fuel cell stack, where we have a inlet and outlet vault, where the inlet valves are available for the hydrogen and oxygen feed, and where we have the terminals available that for hydrogen and the terminals are available for the positive and the negative for out, for taking the output from the fuel cells. This is about the electrical characteristics of the fuel cell. When you look into the characteristics, uh, the relation between that, this is about the power and voltage output of the fuel cell. This is about the loading point, the current density. Basically, it operates in three regions: the activation loss regions, ohmic loss region, mass transport loss regions. Normally, the fuel cell will be operated in this particular region. That is the reverse process. Uh, Here, if you look into that, the when it is loaded, when the current will be getting increased, the voltage is comes down. It means that there is a dropping characteristics, and also the power output from the fuel cell is not a constant like a solar cell. It is a maximum at some operating point. In solar PV, where we have to adjust this the operating point closer to the maximum power point with the help of MPPT controller. Here it is not needed because we can adjust the pressure and temperature, and we can easily control the fuel cell which will operate closer to the maximum operating point. But a final conclusion that so the fuel cell again, it's not a stiff electric source because the dropping voltage characteristics. The actually the efficiency variation with during the energy conversion around 35 to 60%. It's not 90 or 95%, not possible. This is about the basic structure of fuel cell energy conversion systems. uh, we are slowly introducing that the power electronics in addition to the fuel cell for our normal operation. If you look into that, this is the fuel, normally water, in which the fuel is produced with the help of fuel producer, that is hydrogen producer. Hydrogen gas as an input for the fuel cell operation, and it needs oxygen that we are taking the from the external environment, and it is purified and is given as an input to the fuel cell stack. And here the chemical reaction takes place that produce the electricity. The nature of electricity produced by the fuel cell is DC. And again, what kind of DC we are getting? It's a variable DC. It's not a constant. And this is about the the outlet from the fuel cell. There is a no chemical pollutant and no harmful gases. And but water is produced and heat is produced. The same water is used for the hydrogen production, and the same heat also can be used. And if we are slowly introducing that the power electronics here. Here the DC output low, variable nature. So we need a power conditioner. First of all, converting that variable DC from that fuel cell into constant DC. And another thing will be that DC will be a lower value that will be boosted, that will be increased to higher value. So we need a boosting function. And again, that DC has to be converted into AC for operating our the electric motor. Preferable choice would be the electric AC electric motor for our electric vehicle operation. This is about the volt ampere characteristics of the fuel cell. Uh, the conclusion from this characteristics is the DC output, variable DC, it is a dropping characteristics. So this fuel cell output cannot be connected to the load or cannot be connected to the motor directly. So we need a DC to DC converter which will accept the variable nature of uh, DC into constant DC, and also the level of DC has to be increased. That is called a boost. So basically, we are using a boost converter that has a dual function. This is about the role of power converter. Without power electronics, we cannot operate the fuel cell or we cannot integrate the fuel cell with our electric vehicle. The fuel cell produces DC power. It is not a stiff DC source. A stiff DC source means voltage remains constant whatever may be the loading. It is a non-stiff DC source. So definitely we need a isolated or non-isolated DC to DC converter to make that DC is a constant. And again we need an inverter which will convert a constant DC into AC. Again, we need a variable voltage, variable frequency AC supply, which is needed for our motor drive control applications. And so what kind of nature we need a AC that should have a low TST, otherwise that will create some issues with respect to the dragster, the torque ripple, all the things will be coming. Uh, Basically low and medium power output, which is suitable for mobility applications. This is about the two-stage power conversion needed for the fuel cell. Uh, we can select any boost nature of DC to DC converter for our fuel cell operations. Actually, all the researchers are using this similar DC to DC converter, which is suitable for the solar PV systems. There is no specific power converter required for our fuel cell operation. But as compared to the solar PV system, the fuel cell little higher power. So accordingly, you have to design that DC to DC converter. This is about three-phase inverter. So this boost converter produces a constant DC. Okay, and again you need a three-phase inverter converting the constant DC into variable voltage, variable frequency AC, which is needed for controlling the motor, because the electric motor which is used for the mobility is not operating with a particular speed. It operates with a different speed. So the speed control is essential for it. So we need a variable voltage, variable frequency AC supply. So that is provided by the power conversion systems. Again, when you want to design a power converter, the fuel cell converter, actually the fuel cell converter, it means that the DC to DC converter needed for fuel cell operation. That should be a single stage converter. So definitely single stage converter has a higher efficiency than the double stage converters. The converter size should be minimum so that we can easily accommodate it for our electric vehicle operation. Cost, obviously, we are expecting that should be low, and converter should be reliable. So the converter should be a fault tolerant converter. So at any cost, the converter should produce the output, and that should not mean that should that should not produce the false function, or that should not uh, produce that should not make any faulty during the operations. It should be a modular nature so that we can increase the size as you like. And the control scheme for the DC to DC converter should be so simple so that we can easily control that DC output and the electric vehicle. The fast dynamic control. So obviously converter has a fast dynamics, so there is no problem in that. So that it can coordinate with respect to the fuel cell output. This is about the structure of the fuel cell. Just we are accommodating all the parts in the fuel cell. We start from here. This is about the fuel tank, hydrogen tank. Hydrogen is a fuel. That is a inlet for or the input for the fuel cell. This is called fuel cell stack. Here we are using air compressor. So that is taking air from the external environment, and it it produce the pure oxygen. The pure oxygen is the inlet for the fuel cell. And here that the energy conversion takes place where we have a DC output. That variable DC will convert into constant DC, and also the output will be boosted with the help of boost converter and is given to that inverter. In parallel to that, there is a battery. So the battery capacity is not same as the fuel cell capacity. Battery is just a secondary energy source, that's all. So that will supports for some acceleration period and braking period, and it supports for the accessories which is present in the car. And during the fuel cell operation, heat is produced. That heat has to be evaporated, that is evaporated through the radiator. And here the coolant pump is available that will take care of the coolant circulation from the radiator to the fuel cell stack, and from the fuel cell stack to the radiator. And here we are applying that the fuel, that is hydrogen, with a specific pressure and specific temperature, so that the pressure regulator will take care of mm, the supplying the fuel with a particular pressure. Because here the chemical reaction takes place through the thermal condition. It means that the constant temperature and the constant pressure. Uh, Here inverter is used. We know the function. It converts the DC into variable AC. That variable AC is given to the traction motors. So basically, we are selecting the AC motors. Earlier, they used PMSM motor and PMBLDC motor. So nowadays, they are using switch reluctance motor drive. Even uh, the people starts to use the induction motor with vector control. Uh, this is about the final drive which will be connected to the wheel for the propulsion. When you are selecting the traction motor should have some specific requirements. One thing will be the torque to inertia ratio should be very high. Why means if there is the torque to inertia ratio will be very high, then the mechanical time constant will be low. Therefore, it has a good acceleration capability. Actually, what we are preferring, just when we are giving a command, when you are giving acceleration, that the speed pickup should be very quick. That should not be. Okay. The torque handling capability, that is the peak torque handling capability, should be 2 to 3 times that the continuous rating. Actually, in that IC engines, there is a peak value and continuous value will be same, so that that efficiency will be low. Whereas in the electric motor, the peak torque is different than that the rated torque. So the peak torque and peak power should be higher than the rated power. The next requirement will be high power to weight ratio, because we want to accommodate a smaller size motor but higher power output. So normally when you are looking the electric motor which is available in our laboratories is a bigger size even for 5 kilowatt motor. That is not at all suitable for our electric vehicle application, because the electric vehicle application minimum we need 80 to 100 kilowatt electric motor, where the size should be minimum. So we have to design that motor. That motor should have a high power to weight ratio, that then with a small weight or small size motor that produce higher power. This the electric motor needed for electric vehicle application that should operate high speed. That obviously it is available with SRM drive and PMSM drive. Uh, the motor should have a low acoustic noise, because that will disturb the passengers, and it should produce the low EMI, electromagnetic interference, because we are integrating the power electronic module in addition to the electric motor. Actually electric motor doesn't produce any EMI issue, but when you are integrating the power electronic module with the electric motor, that should produce a low EMI. Okay. And it should be maintenance free, and cost that should be minimum. Another thing will be we have here the drive operation in the constant torque region, then again extended to the torque power region, and again we want to extend for operating the drive in the wide speed range. These are the requirements while selecting. These are the requirements should meet while selecting the electric motor. Just like that, we cannot select our normal electric motor for our electric. Normal electric motor is a traction motor for electric vehicle. This is about that energy flow in that fuel cell hybrid electric vehicle. And some places where that energy flow will be bi-directional, some places where you have that unidirectional. You starts from here, the fuel cell just it produces the power, that's all. So it will not get back that power. So the energy flow will be from the fuel cell. It goes to the DC to AC converter also directly. And in parallel to that, there is a DC to DC converter is available here. This DC to DC converter is a buck boost converter. It is bidirectional converter. It means that during the charging, the energy flow from the fuel cell to the battery. During the discharging from the battery to the DC bus here. Uh, where here this again this converter, I mean this inverter, it's a bidirectional inverter. Sometimes it acts as an inverter, sometimes it acts as a converter. During the motoring operation, so when the electric machine operates as motor and produce the mechanical power, it acts as an inverter. And during the regenerative braking, the mechanical power available here that has to be converted into electric power. At that time, the machine acts as a generator. This energy generated during the regenerative braking, again, it is fed back to the battery. At that time, it acts as the converter, AC to DC converter. So this is also a bidirectional inverter. This is called a bidirectional converter. During the braking, the energy flow here and comes to the battery. This red line indicates that that is the electrical power flow indication. Where in addition to that, the traction motor in our vehicle, there are so many electrical accessories. For example, HVAC, heating, ventilation, air conditioning unit, and music and navigation systems, lighting, that is a headlamp, and other lamps which is present in that. So all it needs the electric power. Again, this electric power from the battery. Again, this electric power from the battery. Here you look into that, the energy flow will be in the unidirectional uh, case. And if you look into that, this is the mechanical power produced by the motor, which is a variable nature. So here there is advantage with respect to the electric motor is we can control the electric motor, we can operate the electric motor with specified speed and specified torque. So here the gear changing mechanism is not needed. So directly it is coupled with the vehicle shaft. So there is a no need for gear changing mechanism. There is one speed transmissions. And this is about the energy loss occurs at the different stages while operating the fuel cell electric vehicle. Yeah. So what about the requirements? So actually, just we are saying that the fuel cell can replace with the IC engine, but still you get the same kind of performance from the fuel cell electric vehicle. So, for example, while operating the petrol car or diesel car, we are feeling that we have good experience in terms of acceleration, in terms of braking, in terms of pickup, everything. We need similar requirements from the fuel cell electric vehicle. One thing will be the transient of speed. So we are operating the vehicle at different modes. The starting, then running. In the running, that may be upslope or downslope. Again, there we need to increase the speed and we want to decrease the speed. There is a acceleration mode and deceleration mode. Again, we want to apply a brake. There is a braking or stopping. So these are the modes we need for all the things. How much time it takes? For example, I am operating the vehicle at 60 kilometer. Suddenly, I want to increase the speed to 100 kilometer. So what is the transient time needed from 60 to 100? So that is very important. And for that, the whether the fuel cell system support or is it need any additional support? So for that, the energy storage system, ESS, energy storage systems, will operate in addition to the fuel cell energy conversion system, so that you will get a better dynamic response. You can expect a better dynamic response. And also, it should produce the maximum power while, for example, while starting the machine. The fuel cell quickly has to start and produce the maximum power, even though the temperature will be very low. Because the climatic conditions is not same in all the countries. Some countries where the cold climatic conditions, where the degree Celsius will be even sometimes negative. So even that climatic conditions, the fuel cells to start and produce the power, and because anyhow we want to operate the vehicle. Actually, there are two types of fuel cell electric vehicle. One thing will be a serious a fuel cell electric vehicle. Another one is called a parallel electric vehicle. Here, the fuel cell stack will be a small size, battery will be bigger size. The battery rating will be same to your motor rating. Actually, this is a battery operated electric vehicle powered by fuel cell. That is the architecture. Here's a small size fuel cell continuously running and produce the DC that has to be converted into constant DC that is used to charge the battery. That's all. Then the battery will take care of the whole vehicle. In the second case, that is called parallel architecture. The fuel cell stack size will be same as the motor size. Here, the battery will be a small size that will be secondary energy source. Uh, Here, the fuel cell will produce the power. That power is used for motor operation. That is used for propulsion. During the fuel cell operation, there is a excess of power. It is stored in the battery, and that is supported for accessories and sometimes during the acceleration or deceleration in addition to the stopping. And mostly we are preferring this kind of architecture for fuel cell electric vehicle. This is kind of the power flow diagram. what kind of nature of DC to DC converter is needed? So normally the fuel cell needs the DC to DC converter, that is the boost converter. That is a normal DC to DC converter, that is the unidirectional power flow. Whereas the converter needed for the battery that supports for the charging and DC discharge. It means that energy flow will be in two different directions. So that is, here we are using a bidirectional DC to DC converter. Here we are using the unidirectional DC to DC converter. This is about the discharging from the battery. This is about the charge during the battery. Still a little more improvement. Still you need a very fast dynamic response from your vehicle. You have to add, there is a one more energy storage device called the supercapacitor. As compared to the battery, the supercapacitor is a highly dynamic nature. It is capable of supplying, that is a larger power in a quicker time, and also it is capable of charging a large value in a shorter time. For example, so during the battery, so under the normal operation there is a no role of supercapacitor. Okay, so under the normal operation the fuel cell is giving a power to your drive. So for example, this is a base power. So in addition to that base power, we need little higher power. Okay, the longer time, that the additional power can be supplied by the battery. And where the supercapacitor plays the role means, so where we need the very huge power in a shorter time. So here we need a huge power from the shorter time. For example, during the starting of the vehicle, during the startup. So at that time, this the supercapacitor is capable of providing high power in a shorter time, but the energy density will be low as compared to the battery. That is a problem. We cannot store very high power as like a battery. Okay. So then another role will be during the braking. So normally the energy availability available only in a second, in terms of seconds. Within a second, we have to get back that energy. You within a second you have to store that energy. So within a second it is very difficult to store the energy from that vehicle. So this super capacitor is capable of store that energy in a shorter time. So this will support for higher energy conversion systems in the fuel cell electric vehicle. But when you are adding the supercapacitor, again it increases the complexity, it increases the cost. Oh, I stopped here because already one hour over. As per the coordinator mentioned, I stopped the session here, and
We will resume back after 15 minutes, sir.
yeah.
Now, 8:05, sir. We will resume back by 8:20. Is it okay, sir?
Okay, sir, no problem for me.
Okay. Participants, please have a break for 15 minutes and come back by 8:20. Thank you, sir.
Okay, sir, thank you. Sir, kindly allowed to share the screen, sir.
Just a minute, sir. Just a minute, I will give you the.
Oh, okay, sir. Okay.
Yes, sir. Now you can share your screen, sir.
Oh, okay, sir. Sir, is it okay?
Yes, sir. Okay, okay. Visible, sir. Voice is also clear, sir.
Okay.
You can.
Yeah. This is about the fuel cell coordinated systems, where we need a fuel cell separate control systems for the fuel cell operation and a separate control systems for the power electronic controller needed for our electric motor drive, which is needed for our electric vehicle. Uh, Here, this is about the main DSP controller. Similarly, there are some DSP controllers, DSP controllers are available that take care of that individual part control. Uh, this supervisory DSP controller will take care of controlling that fuel. Actually, the fuel will be combined with the steam that is called reformed fuel, that is given as an input to the fuel cell in order to improve the energy efficiency. And this operation, and where you have to control that DC as well as the AC. In addition to that, there is a control signals from the main controller that will control the inverter operation so that the AC power will be controllable, which is needed for the electric motor drive. Here we are using two sources. One thing will be fuel cell, that is the main source that will provide a constant electric power output that helps for the stable operation. In addition to that, so normally the fuel cell will be running continuously with a particular power output so that efficiency, energy conversion efficiency will be high, and maximum power output, and also it operates with the maximum power point, so it produces the maximum output power. In addition to that, the batteries are supporting for the variation in that energy during that energy conversion. This is about the how the arrangements made in the practical car. It is taken from the Hyundai. It is available in the market, and we're looking the infrastructure of the car. Uh, this is about the fuel tank, like our LPG tank. The hydrogen tank stores the hydrogen, so normally liquid form will be stored here. And the second one will be, this is called the fuel cell stack. It produces the electricity, and this is called a lithium ion battery. So mostly we are preferring the lithium ion batteries, so because of high energy density and the uh, smaller size, which stores the electricity. This is about that power drive unit, which will control the, this is about that power inverter, bidirectional inverter, which will take care of the drive control and the motor speed control and torque control. So this is called the power drive unit. And the fifth module will be called the electric drive, that is electric motor, which will be coupled with the uh, vehicle for the vehicle propulsion. The actually the electric motor, which will be coupled with the power drive unit, which will produce variable speed operation, which is needed for the electric vehicle operation. This was about the infrastructure of the electric vehicle. This is very simplest structure. So nowadays a lot of new technologies are coming in the automobile industries, especially for that the fuel cell electric vehicle, mostly for a sophisticated environment. So in which we are looking only the fuel cell electric vehicle drive systems. The major components present in the fuel cell electric vehicle is the fuel cell electric air compressor, fuel cell pump and fan. We will look all the parts. The fuel cell DC to DC converter, that is the boost converter. Fuel cell control unit that will take care of the fuel cell operation. The safety and the security module, traction inverters, high voltage traction batteries. In addition to that, these major modules, so we need some supporting subsystems for the fuel cell electric vehicle. The main important one will be the super insulated double walled hydrogen tank with the pressure of 350 to 700 pound. So this is very important because so while thinking about the fuel cell electric vehicle, is there safe? So definitely the fuel tank is safe means the vehicle is safe. Remaining parts of the vehicle is not an issue. Next one will be hydrogen injector. Hydrogen pump. It is normally we are feeding the hydrogen with the specified pressure and specified temperature, where we have to regulate the pressure. That is done through the hydrogen pump. Air compressor, already mentioned that. So it is responsible of taking air and purifying and sending the pure oxygen. Um, the fuel cell pump and fan. So that is taking care of thermal and water management, because during the fuel cell operation, a huge heat is produced. That heat has to be taken out. Uh, that is the thermal management and pressure regulative valve injector. So all the things needed for the hydrogen fuel. Uh, and another thing will be we want to monitor the operation of the fuel cell by sensing the voltage, pressure, temperature, and we have to sense whether is there any leakage with the help of proper sensors. In addition to that, the fuel cell control unit, that is called the fuel cell coordinated control, that take care of the process control in the fuel cell. Here we are looking only the major parts. The major parts will be air compressor. We know that uh, fuel cell needs the pure oxygen in order to produce the electricity that is normally feeded in the cathode side. Okay, and that air is taken from outside and is purified and is fed into the cathode side. Another thing will be, so the main role of air compressor system will be taking care of controlling the airflow rate, because we have to send the oxygens in the particular flow rate with the particular pressure. So these parameters to be monitored and controlled. Another parameters to be considered while designing the air compressor, that should be a efficient one. So that is the obviously for any subsystem design, it should be efficient, and dynamics over the wide speed range, because we want to control the fuel cell by controlling the fuel as well as the oxygen. It should be compact, modular nature, so that it can be easily increased, the size can be easily increased when it is needed. Low noise emission, that should not produce any noisy during the operation. Safety, so it should not make any contamination during the fuel cell stack, because the fuel cell stack is costly. So if the air compressor is not doing its own function, then what happen means, if any impurities present over that oxygen, that will pollute the that will contaminate the fuel cell stack. This is the role of the air compressor. The fuel cell pump and fan will take care of supplying the hydrogen and regulating the pressure. Regulating pressure, and also it will take care of the thermal management, because so the heat has to be properly dissipated through the radiator through the fuel cell pump. This is the main unit for the fuel cell control, fuel cell operation. This will control the total process of the fuel cell. That will take care of the supervision of hydrogen injection, airflow rate, thermal management. It means that there is a cooling system management, energy conversion, and all safety issues, all safety and security issues. For all the places they are placing sensors, and based on the sensor output, it will monitor, and it will any abnormality identified, so it stops the total process. And in addition to that, so it has to provide a power to the load requirement. So there is a close interaction in between the fuel cell controller and the powertrain domain controller. Then another important thing will be already mentioned, that the fuel cell DC to DC boost converter is very important role, that will interface with the fuel cell stack output with the traction inverter. In addition to that, it is an interface in between the fuel cell output with respect to the traction battery. Okay, so there is a how we are designing the DC to DC converter. Again, when you are using the conventional MOSFET and IGBTs, the problem is the size of the converter, because you hardly you are looking that the fuel cells is supplying around 100 kilowatt power, in which it has to take care of the 100 kilowatt power level, which will be needed for our traction inverter. So the size of the converter should be bigger. So instead of reducing the size of the converter, the reason scenario the peoples are using silicon carbide power modules. So silicon carbide IGBT modules are available, silicon carbide MOSFET modules are available, uh, that has a low switching and conduction losses, so that efficiency of the converter will be little higher. When you take about that converter ratings, for example 500 watts, 300 watts, then there is no issue about that conversion efficiency losses. Whereas when you think about the converter for 100 kilowatt, then that losses plays a major role and the efficiency plays a major role. So the silicon carbide power devices are chosen means that has a low switching and conduction losses, even at very high switching frequency, that improves the converter efficiency. Another thing will be it reduce the size, and the power density can be increased. Power density will be can be increased. It means that even a small converter, a small size converter, capable of handling high power, which is needed for the electric vehicle operation. Because when you design the car, so for example, this is about the car. It consists of lot of sub modules. All the sub modules should be so compact, should be so compact, and it can be accommodated without any interference with respect to the spaces for the passengers. Another thing will be nowadays, so because we have to introduce the separate controllers, there are many controllers available. Each each controller will take care of the individual sub model. So We need higher end microcontrollers for producing the pulses for handling the silicon carbide MOSFET or IGBT modules present in that converter. So normally they use the 32-bit digital signal controller, that is a higher end floating point DSP processors are used for producing pulses, and we need integrated gate drivers for the DC to DC converters and also for the traction inverters. And this is about this recent scenario, and these points to be considered while designing that converter for our electric vehicle operations. We cannot substitute the conventional converter and inverter modules as like our motors for our electric vehicle applications. So you need a dedicated converter, you need a dedicated inverter and electric motor for the electric mobility operations. This is a very important unit for the fuel cell electric vehicle. So traction inverter, uh, which controls the fuel cell electric motor, which which is responsible for the vehicle driving performance. So the total drive performance based on your the motor control. You need a smooth control, or you need a smooth operation over the vehicle. Okay, and for that your motor performance will be decided by the traction inverter. Traction means the inverter which is suitable for your traction motor, that's all, nothing else. uh, and what about the power rating? So the power rating will be same as the motor. For example, when you are using the 100 kilowatt electric motor, you need a 100 kilowatt traction inverter, where that silicon carbide IGBT modules are used, and which is controlled by the digital signal controller, and in which we are taking care about that the conversion efficiency, thermal efficiency, so that is suitable for the long drive. So why the thermal efficiency has to be improved means, well, for example, when you are operating 100 kilowatt inverter continuously, so there is some losses, for example, conduction losses and switching losses, which will 1 kilowatt inverter means no problem. So you can easily, that heat will be dissipated through the heat sink. So when you take about 100 kilowatt inverter, and the heat dissipation should be proper, so that it is suitable for the long drive operations. Otherwise you will get a signals from the inverter, so while operating over a 2 hours 3 hours journey or 5 hours journey continuously. This is about the basic diagram for the traction inverter. If you look into that, this is about the high voltage battery. For example, a 500 volt battery. This is about the DC link capacitor, which will maintain a constant DC to this IGBT module. This is about the three-phase inverter. So based on the pulses are given, we will get the AC output. That AC will be variable nature in terms of voltage and frequency, because we want to control that the motor. Actually, the motor will be operating different modes. One thing will be starting from the operation from the zero speed, then acceleration, increase the speed from one level to another level, deceleration, decrease the speed from higher level to lower level, stopping. So again, regenerative braking. So all the operations will be controlled by this inverter. uh, how this inverter is working? So we need a dedicated pulses. For that we are using a 32-bit digital signal processor uh, for producing the independent pulses, that is given to the IGBT driver module. I Because the pulses from this controller cannot directly given to this devices, because these devices will be floating nature, so you cannot give all the pulses directly. It will be given to the isolation and driver module, then it is given to the power module of IGBT power module. Okay, and normally it is a closed loop operation. We are continuously monitoring the inverter output. Okay, and how the inverter output will be sensed by sensing that voltage and current that is given as a feedback to the controller. In addition to that, so we want to operate the drive in a closed loop, so we are sensing the rotor position. That information also given as a feedback. We have to sense the actually the thermal monitoring also to be done in the inverter, so we have to sense the device temperature, that is a heat sink temperature, all the things. So that has to be given as a feedback, and based on all the feedbacks, it provides the control signals. So that is very important. In addition to that, in addition to that, the driver will give some command. For example, in increase in the speed, decrease in the speed, and all the things. So that also to be taken, take part of it. Then another thing will be, in addition to that high voltage battery, there is a low voltage battery is also available that will take care of the electric accessories present in that electric vehicle, and that will provide a supply to the sensors which is present over the thing, and all the sensors will be connected to the main controller through the CAN transceiver. So there is a controller area network transceiver, and all the inputs will be taking care by this main controller. Accordingly, the main controller command or control pulses will be produced. That control pulses will modify that inverter output, that will modify the motor output, that the motor output will directly change the performance of the vehicle. So this is the role of the inverter. Actually, when you think about the normal inverter, that will be slow dynamics as compared to the. So we want the dedicated inverter module which will be suitable for automobile application, that should have a higher dynamic response, that should have a faulty tolerant. Okay. The magnetic position sensors are normally used in the drive, for example, in PMBLDC or SRM drives, where that speed control, in addition to the speed control, is possible with the help of only the rotor push. This is the silicon carbide power modules are available for the automobile applications. Uh, this high power density power modules are more suitable for the uh, electric drive applications, especially for the fuel cell applications. The main advantage of selecting the silicon carbide devices, it has a higher power density, less cooling effort, and lower number of passive components, less number of passive components, so that we can reduce the size of that power module, so that it is a compact, it can be easily fitted to your electric vehicle. In the traction inverter, again I mentioned that it is a high power inverter, where the conventional VSI, I mean voltage source inverter or current source inverter, is not suitable. We need a higher end PWM inverters for this particular applications. Normally, the when you choose the two level inverter for high power applications, these devices are connected in series, but practically speaking, it is available in a module. So this is called the device pack. So we can use the device pack instead of single device for designing a three-phase inverter, which is needed for our traction applications. Again, normally the inverter control is possible with the help of sinusoidal modulation or space vector modulation. Sinusoidal modulation is quite compact and easy control, and practically easily realizable. So the sinusoidal space vector modulation is selected for the traction inverter control, where we can easily control the voltage, we can easily control the frequency, and the output contains the output should have the low TST. If it contains a higher TST, especially for the negative sequence harmonic, which will produce the torque which is opposite to the original torque, so that will have some issues with the drive's operation. So while designing the traction inverter control, so you have to take care of the negative sequence harmonics. Positive sequence harmonics no problem, but the negative sequence harmonic is dangerous for the electric vehicle application, so that will damage the coupling, mechanically coupling. The other choice for the high power inverter, for example 100 kilowatt inverters, are multi-level inverters. So multi-level inverter is a power conversion system, so composed by power semiconductors with capacitive voltage sources that will produce the variable voltage, variable frequency, a step waveform which will be closer to the a sinusoidal waveform. So there is no separate filter is needed for the multi-level converters. When you are selecting the traction multi-level inverter as a traction inverter, it has a low harmonic distortion because that is essential for the motor performance, and that also desired the that is also important for the torque ripple, and the reduced voltage stress on the power device with inverter that improves the lifespan of the inverter. Okay, low acoustic noise and EMI, because this is very important aspect while designing the traction inverter, because for example when you select a 100 kilowatt inverter that has a high EMI problem, means that will interfere that the communication devices which is used by the passengers. So for example, when you are operating your laptop or your mobile with 5G or 4G, so that will be interrupted by the EMI produced by the inverter, which is a part of the drive control. This is one basic structure can be used for high power application. There is a 3-level neutral point clamped inverter, which has a low harmonic distortion as compared to the low level, and also it is capable of supplying higher power than that the normal 2-level voltage source converter. This is about the harmonic analysis because without filter, this is about without filter. So if it is connected to the motor load, all higher order harmonics will be eliminated. For example, here all the higher order harmonics will be eliminated. Only a few lower order harmonics will be available that we can be easily filtered out. Then another option, still, if you go for the bidirectional operation, for example, when you select a 100 kilowatt inverter, that is sometimes it will operate as the converter, that sometimes it will operate as inverter, dual function. So this is the best choice while going for a bidirectional operation, the modular multi-level inverter. So mostly it is used for integration of the solar PV systems and grid integration of solar PV systems and wind energy conversion systems. This the futures of modular multi-level converter is more suitable for our electric vehicle operation. Again, it is up to you. In addition to that, the normal fuel cell DC to DC converter, we need high voltage and low voltage interface DC to DC converter, because normally in the vehicle there are two different kind of batteries are used. One thing will be high voltage battery, another one will be that is called traction batteries, another one is called low voltage batteries. So low voltage batteries will take care of the vehicle accessories. So the converter which will be suitable for interfacing the high voltage traction batteries as well as the low voltage vehicle accessories batteries. Normally this is called a design. So high voltage battery and low voltage batteries, and the power exchange in between the high voltage and the low voltage batteries. So how it is sensed and controlled by the microcontrollers. Yeah, this is called auxiliary inverter. The main inverter supports for the electric motor for the propulsion. The auxiliary inverter supports for the auxiliary drives, which is used for HVAC application. That is a heating, ventilation, air conditioning unit. So anyhow, when you are using this module, that should be energy efficient. So nowadays, even our home appliance, home applications, now our inverter ACs are available. It means that the compressor speed will be adjustable. So adjustable by the help of PBF control methodology. That's all, nothing else. So the same principle can be applied for HVAC systems also. There is a heating, ventilation, air conditioning. In our car, we have three options: heat, cooling, fan operation. That is called HVAC operation. That is normally done through the drive. So the drive will be controlled with auxiliary inverters. Again, it improves the energy efficiency. That's all. Because so when you go for energy efficient control, you can reduce the size of the battery. That is the advantage. Yeah. So while selecting the electric motor, so what are the points to be considered? Because our conventional electric motors cannot be used. So definitely we need a dedicated design for electric vehicle operation. Because in that electric vehicle operation, the electric motor used as a drive, we need a power converter plus electric motor, because we are not operating the motor with the constantly, we are operating with the motor with the different speed and different torque. So that is controlled through the power electronic systems. So I think we have mentioned about that energy storage systems. Energy storage systems support the acceleration, deceleration, and braking operations in addition to the motoring operations. So normally we have a battery pack. So that is the batteries are connected in series and parallel, that will be placed for energy storage systems. Yeah. And if you look into that, so I already mentioned that. So when you select the motor, that should have a high power density. The normal motors cannot be used. So we need a small size, very high power output motors that should have a good power control, and that should have a higher dynamics. Yeah. Uh, Power requirement is not a constant. Even if you look into that, for example, when you are operating the vehicle in the normal road with a particular speed, with a normal speed, then power requirement is less. When you want to suddenly increase the speed, when you want to increase the speed, so you have to provide a higher power. So during the normal operation, so the power requirement is normally less. When the power requirement will be more during the starting, so we during the acceleration again. So within a short period, we want to give we are giving more acceleration within a short time to increase the speed very quickly. So at that time again it needs more power. So normal operation just to 20 horsepower. So when you are increasing this speed from 65 to 95 in the normal road, so you have to apply higher power. Even with this speed transitions, normally when you start that vehicle, initially we are applying the higher quick we are giving more acceleration for increasing the speeds quickly. So at that time we need a peak power. In addition to that, so the power requirement for the accessories and There are losses in all the models. While selecting the battery, so you can look into the power density. Based on that, you can select the batteries. Normally, lithium-ion batteries are used. Uh, yeah. So while selecting the electric machine, not motor, because the same machine can be used as a motor or generator. Because motor during the normal vehicle operation, braking during the generator during the braking operation. So that should be energy efficient motor. So it should be a high conversion efficiency, and while selecting the higher conversion efficiency, that will take lesser power. If it takes lesser power, we can reduce the size of the battery, we can reduce the size of the fuel cell stack. When you're reducing the fuel cell stack size and the battery size, you can reduce the space and you can reduce the cost. This is the advantage. So while designing the sub modules of the electric vehicle, all the sub modules, wherever it is possible, it should be a highly efficient one. It should be highly efficient one. That should not increase the vehicle weight also. There are two kind of motors are used. One thing will be a permanent magnet motors. So we have a category of permanent magnet brushless DC drive, permanent magnet synchronous motor drive. Another thing will be induction motors. So nowadays, induction motors also used with vector control because of very less maintenance, and it is low cost. And some vehicles where the peoples are using switch reluctance motors also, where you need a high speed operations. Yeah. This is the speed torque curve of this electric motor, which is needed in this electric vehicle operation. Normally, this is about the continuous uh, torque output. Up to base speed, the torque will be remains constant. Again, the torque comes down where the power will be constant. That is called constant power operation. Sometimes it takes the peak power, which will be 2 to 3 times more than that. So even that motor will be capable of supplying that. And sometimes it takes intermediate power in between the rated power and the peak power. Peak means the maximum power. So the motor also has to supply both constant torque region and constant power region. So the peak power output only for a short time, not for all the things. Yeah. And in addition to that, the motor should operate in all the four quadrants. It means that because we are operating the vehicle in forward direction as well as in the reverse direction, and we are applying a brake while driving the vehicle in forward direction, while driving the vehicle in the reverse direction also. So your vehicle should operate in all the four quadrants. These are the application areas. So not only the cars, the fuel cell vehicles are so popular with respect to the buses and the truck vehicles. So mostly the manufacturer are thinking about the high power vehicles. This is about the trucks, bus, delivery vans, refuse. So all the things are more available in the market in the foreign countries. Yeah, this is about the fuel cell electric propulsion for ship, and even government of India, Indian Navy have a fuel cell electric ship, electric propulsion, where that the cost is not a major factor. So they use uh, the fuel cell systems for driving the ship. Uh, this is about some of the models which will be available in this. Then another major aspect will be the hydrogen storage systems. So we need a dedicated hydrogen tank that should be fully insulated. That is the double coated and double core wall systems for storing the hydrogen. Okay. So one advantage is the actually the hydrogen gas in the atmospheric pressure have a low energy density. Directly it is not suitable, so the hydrogen has to be compressed in a liquid form, and or in the more advanced with the help of like a metal hydride, or by using that carbon monotubes, and it is stored in the hydrogen tank. Normally it is a liquid form, it is stored in the hydrogen. So when you are compressing the hydrogen, so you need more pressure. So that you have to so you need a dedicated systems for compressing the hydrogen and storing in the fuel tank. Yeah, so very important thing will be, so whether it meet the safety matters. One thing will be the electrical safety. uh, the regulations are available, so the electric vehicle should meet these kind of safety standards to be maintained. One thing will be the protection against the electric shock. So you have to provide a proper wiring inside that electric vehicle. That should not disturb, or that should not uh, damage the passengers. Another thing will be we are using a refrigerant HVAC systems that should not make anything sing on all else electrical safety aspects. In addition to that, the fuel safety, and when that the vehicle will be subjected to the accident or in the collide subjected to the accident. So what are the safety standards to be maintained? So all the things will be meet out by whether it is the battery operated vehicle or fuel cell electric vehicle. Yeah, this is a very important thing. So is the hydrogen vehicle dangerous? uh, Hydrogen gas is highly flammable. Okay. It can form explosive with the with mixed with the air. So we need a proper production while storing the hydrogen and while using the hydrogen, while using the hydrogen. But the problem is hydrogen is safer than the petrol and diesel, because so it is lighter than the air, because hydrogen is the lighter gas. So even any leakage, it will be easily mixed out with the environment. So that will not affect much. But a lot of research is going on of the hydrogen storage systems and the safety standards with respect to the hydrogen handling. Yeah. Um, Even though there are a lot of research is going on the fuel cell electric vehicle and electric vehicle, they are facing a lot of technical challenges. One thing will be cost. Since the technologically it is a proven one, the fuel cell electric vehicle is not in the market. It is in the market, but the price is a little higher, so that the peoples are not preferring the fuel cell electric vehicle. And another thing will be the refuel infrastructure, like our petrol punk and diesel punk. So we need the hydrogen fuel stations in all the places. And again, lot of work has to be done for the creation of the hydrogen refill infrastructure. Then the safety, a lot of research going on that the safety issues, insufficient vehicle range. Um, Another thing will be the starting mechanism at very low temperature. Again, we how to increase the power density of the fuel cell. Nowadays, the higher end fuel cells are available with a high power density. That is not a problem. So we have some research issues also. You can work towards the energy storage systems, both hydrogen energy storage systems as well as the electrical energy storage systems, PMS battery management systems, and vehicle management system or vehicle management control. Then power electronic design for the fuel cell electric vehicle. Then the powertrain system integration for hybrid electric vehicle. So you can work in this particular field. And also you can think about the converter that should operate, the single converter that should operate with constant mode, accept variable DC, and capable of producing the AC output, which have a low TST output. It means that the harmonic free output. Another thing will be normally while designing the converter, the current ripple of the converter decides the lifespan of the fuel cell. The current ripple will be low, then that will increase the lifespan, because the costliest system is the fuel cell in that fuel cell electric vehicle. So the fuel cell lifespan is very important. Another thing will be you can design that converter and inverter and bidirectional converter and bidirectional inverter with reduced losses and improved efficiency. Another thing will be very important thing will be modular. All the converter systems should be in modular nature, so that we can increase the size, we can increase the power rating. Yeah. What about the concluding remarks as per the fuel cell electric vehicle? As compared to the pure electric vehicle, we can refuel. So it takes 3 to 5 minutes maximum. Okay. The full electric powertrain providing intermediate torque for the whole drive, and which will help for relaxed and responsive drive. So compared to the battery operated vehicle and IC engine vehicles, so it will be smooth control and virtually silent operation for occupants and the outside the environment, uh, which will not produce any noisy and which will not produce any pollutant gases. Uh, Even the maintenance also will be less because the fuel cell stack will be recyclable like a battery. Here, increasing the travel distance is not a issue, because we can increase the storage capacity, we can increase the size of the fuel cell. Um, Hydrogen is 100% renewable, so it is available with free of cost. Only we are spending the cost for that hydrogen production. The source for the hydrogen production is free. Hydrogen can be stored and transported without any loss. That is not a problem. So with this advantage, so definitely the fuel cell powered electric vehicle will dominate the electric vehicle market. So that is my conclusion. Thank you.
Thank you very much, sir. We are very happy. It is an excellent presentation, and we have some knowledge, good knowledge about this fuel cell electric vehicle. Your presentation, you have overcome your health issues, and you make a wonderful presentation that we realized while your cough thank you very much on behalf of the participants and my behalf. Participants, it is a question time. You please feel free and clarify your questions with resource person, Dr.C. Please.
Thank you, sir. Thank you for this wonderful opportunity. Dear participants, if you have any questions, you can raise.
Hello.
Yes, please.
Good evening, sir. My name is Dr. Amit. So one question, like many electric and these hybrid vehicles are coming, like hydrogen-based electric vehicle. We also according to you, which will be good? Like for the end user, which vehicle would be good? And what is the future of no, like different techniques are coming. So which has got the good future in it?
Technology point of view, fuel cell electric vehicle is good, but only the problem is cost. So you have to spend 50 to 60 lakhs, which will be double the times as compared to the conventional battery operated electric vehicle. That is a problem. So where that fuel cell electric vehicle is lagging, and the performance wise also the fuel cell electric vehicle is good, maintenance everything is good, but when you think about the long term, and when you think about you are not worry about the cost, then the fuel cell electric vehicle is good choice. Hybrid electric vehicle is a good choice as compared to the battery powered electric vehicle.
Thank you.
Participants, any questions?
Good evening, sir. This is Venkatesh from Chennai.
Yes, please.
As per the stoichiometry, 1 kg of hydrogen reacts with 8 kg of oxygen to produce 9 kg of water. And I have not seen any how to dispose water, because you are burning huge amount of hydrogen, which is simultaneously producing, because in moving cars, you cannot regenerate the hydrogen and oxygen instantaneously from water that is produced. Water has to be disposed of, which will be hot also. What is the provision for this, and how we are going to tackle this problem? Question number one. Question number two, purification of highly polluted air to oxygen is a highly challenging issue. I don't know how they are trying to attain, because as far as fuel cell is concerned, purity is very important with respect to both hydrogen as well as oxygen. There are two issues. If you can address it, I will be happy. Thank you, sir.
Okay, fine, sir, fine. The first of all, the water is not, it is not necessary to dispose the water. The same water can be used for the hydrogen production, but the hydrogen production is not part of that. Actually, it is not part of that the fuel cell car. Actually, as you mentioned that it won't produce the huge amount of water. Normally we are producing the hydrogen separately, and we will store in that hydrogen tank. That hydrogen will be only used for our fuel cell stack operation. During the fuel cell stack operations, as you mentioned, that a huge amount of volume, huge amount of water is produced. So no, a huge amount of water is not at all produced. So only yes.
Yeah, as per the stoichiometry, it is 1 mole with half mole gives you 1 mole of water. When it comes to mass, when 1 kg of hydrogen is consumed, you invariably land up with 9 kg of water, because 8 kg of O2 will combine with the H2, which has to come as 9 kg of water.
No, and I will check that the
please.
equation, and
No issues.
absolutely is no, there is a 9 kg of water is not produced from during the fuel cell equation. I will check that the equation. Then another question is what is your second question?
Air compressor. Air compressor, how
Yeah.
it can
So
pure highly
the air
polluted
purification,
air.
air purification during that. Again, so still a lot of research is going on in that
That is
air
one hurdle.
compressor design to purify the water which is taken from the okay. So because even a small pollutants in the air that will contaminate the fuel cell stack, there is no doubt on that. So the automobile industries are looking on that particular thing. So there is no problem with that. So the production of the pure oxygen is not an issue. So hydrogen production is the tedious task, but oxygen purification is not a major issue as compared to the hydrogen production.
But I feel still a long way to go, sir. There are major technical
Yeah,
efforts.
the
Many has to
only
be adopted
this is
to the
only in the
market.
research level. So it is a technologically so good, but commercially still it is not in the success. I can claim that. But so again, so it takes another few years, a couple of years, so that so there are a lot of inventions or a lot of modifications done in terms of fuel cell, in terms of hydrogen storage. Then only we can get that technology in that road which is feasible.
That's correct, sir. Thank you, sir. Thank you very much.
Thank you.
I have one question, sir. Sir, if we are using fuel cell, so additionally one converter stage is required. So that will reduce the efficiency of the vehicle, isn't it, sir?
Definitely, sir. So definitely, when you look into the overall efficiency, when you are adding more number of converters, so definitely that overall efficiency of the system has to be reduced. But we have to provide the alternate solutions, sir. No other way, because the fuel cell is providing a variable DC. So in order to make it to constant DC, you need additional converter that has some losses. So when you take about the overall efficiency, it will be comes down.
Yes, sir. Yes, sir.
But actually the peoples are thinking in that particular fashion, sir. For example, if you take about the battery operated vehicle, it needs the electricity, it needs the DC power, again it needs AC to DC conversion. Again virtually speaking, some virtual AC to DC converter also will be a part of your battery operated vehicle, that also having losses. In that way the people compare them.
Okay, sir. Thank you, sir.
Thank you. And one more point I want to add. As per actually, as compared to the thermal efficiency and mechanical efficiency, our electrical systems are good. So the efficiency of the converter, efficiency of the inverter, and efficiency of the motor all are high. All are high as compared to the fuel cell efficiency. Fuel cell efficiency will be around 20 to 40%. Your solar PV efficiency again less than 50%. So as compared to that, our efficiency is good. Then we need not worry about that the stages, sir.
Okay, sir. Okay. Yes, participants, any more questions? Okay, if there is no question, we will wind up the session. Thank you very much, sir. Once again, thank you very much for sparing your valuable time in the evening.
Sir, 1 second, sir.
Yes.
Sir, feedback form is available in chat box. Participants just make the feedback form. The link is available in chat box. Thank you, sir.
Okay. Okay. Thank you. Tomorrow's session, it will be handled by Dr. B. Venkatesh Perumal, Professor, Electrical and Electronics Engineering Department, NIT Surathkal, Karnataka. The topic is solar-based EV charger and system impact with grid. So this is the topic of tomorrow's session. So I ask all the participants to join the tomorrow's session. Before that, you fill the feedback form which is provided in the chat box. You please fill and leave the meet. Thank you very much for joining. We will meet you tomorrow. Thank you, sir. Govindaraju, sir. Thank you.
Thank you very much. So at this juncture, I want to thank management, principal and coordinator, Dr. P. Kannan sir, and especially I thank all the participants for listening my words for last 2 hours. Thank you very much and thanks again.
Okay, sir. Thank you.